Okay, I can start recording. So, okay, this builder pattern, what we want is we would like to, so we would like to, so we know that in this builder pattern we have what? We have 4 participants. Can someone tell me these participants? Or I can even say 5. Let's do 5. I already created the layout for you. Oh goodness, can I change it now? Yeah. So we have client, right? As usual. The one who is consuming, client is the one who's consuming our pattern, okay? Is the one who really needs this solution. So the client needs the solution, right? Client needs to have this dynamic object, okay, which gets which can be constructed subsequent kind of in a continuous steps. Then what do we have? Hello. So okay, we have a director, right? We have director, right? You agree with me?
Yes, yes.
So director, what does it do? It aggregates, or composed of, in this case, composed of, not aggregates, because director cannot exist without this guy. With what? What is the name of this guy? Director has a construct method. Director has a construct method and something. What is that?
Product.
No, come on, guys. What is the name of the pattern? Builder, right?
Yes, yes.
Yeah, it's an interface, right? It's an interface, right?
Yes, yes.
Okay. Yeah. So I can make this one as an interface too, because I'm associating with them with my client. I don't want my client to be, okay, it's associated with this builder as well. And it's also associated with this thing. Okay, so what is this? It's a builder, right? So I need a builder object. Okay, so what builder contains? Yeah, I mean, let me get rid of this I now because I already have this aggregation, all that stuff. Okay, interfaces. Anyway, right? Yeah. So what do I have now? I have some methods, right? I have some methods, right? Called build part A, build part B, and etc. Whichever are the parts, it goes and builds, right? You agree with me?
Yes, yes.
And at the end, I have a method called get result. So it basically, okay, it builds the parts and then it can get result, assembles the parts, and then returns you what? Returns you the product, right? So it is, we have the product here. Yeah. So we have the product. Yeah. So it is associated with this product in this case. Yeah. Agree with me?
Yes. Yes.
Because it returns this product, right? Okay, so now I have a concrete builder which implements that. Okay, and this builder will know how to prepare the part 1, how to prepare the part 2. So it basically implements all that, all these methods, right? Part A, part B, and so forth. And it knows how to assemble these parts into one. Right? Yeah? Okay, what this constructor method looks like. Sorry, construct method would look like. Okay. What does the construct method look like? So it's a void. Yeah. Tell me. This builder. What? The order, right? It's some order, right? Build part A.
Part A.
Part A, if it's necessary to build this product, okay, this thing, this. So it knows it. I mean, this is the logic, okay? It's not necessarily that everything should be built in this order, okay? This is basically the logic, your logic, how you're building the part. The director knows, given that you can prepare the components, it knows in which order, okay, they need to be built, okay, or and which parts can be skipped or which parts can be included. It knows it. It implements that logic. This is the chef, okay? The director is, let's assume that you're preparing a dish. This is a chef, and this is the guy who supply. This is the supply manager, okay? He brings the ingredients to you and then say, okay, now I need to put some oil into my pot, and then I'll put some onions into my pot, and then I'll just put maybe some meat into the pot, okay? You got the point. This guy is the chef guy. This guy is the guy who prepares the ingredients for you, brings the ingredients. So if you want to make a pilaf, you need a pilaf director and you need a pilaf builder. Okay, so pilaf builder has methods. Let's say, give me rice, give me this one, give me that one. Okay, but if you want to with the same ingredients, okay, you want to build something else. Let's say not pilaf, but let's say some soup. Then you can also take the builder and have same ingredients, or maybe you skip some of the ingredients, but you do it in a different way. Okay, you got the idea. And at the end, you ask the builder. The client will ask the builder. First, client will ask the chef to prepare. Okay, first client will instantiate, okay, or get the instances of the director and builder. Okay, and then pass the builder to the director, because chef needs the builder, right? You see this aggregation here, there's a composition here. He passes it to the director, and now director goes and asks, client will ask the construct method. Now client goes and asks the construct method, the chef prepares the pilaf, and then he goes and asks the builder to give the pilaf, okay? Because pilaf is in the pot, right? Chef is the one who is managing the process, is putting everything into the pot, right? You got the idea. And at the end, then at the end you got the pilaf, because get result would return you the pilaf. Okay. Is it clear? Is it clear?
Yes.
Yes.
So in this case, in this particular realization of this builder, it is assumed that you can have multiple different ingredients for different parts, right? So in this case, like because the build the part A, part B, in one implementation, part A could be something else. In other implementation, part A could be something else. It is not exactly the same, right? In this particular realization, you might have multiple builders which prepare different ingredients for the same chef, okay? For the same chef, right? You got the idea?
Yes.
Now you can reverse this process. You can make it opposite, okay? Still, okay, the structure doesn't change, but again, the structure will be the same. Everything will be the same. Instead, the builder will be a concrete kind of class, or it can be an interface as well. You can leave it like this, but now you make your director an interface, okay? And now, okay, director, you can even say it aggregates on an interface level. Yeah, make it interface. And on a concrete director class, you decide how to re-implement the construct method. Okay. So you can have, this is a T builder. This is a T maker. Okay. And T builder gives you all the ingredients like the water, the tea, the sugar, the milk. Okay. And the sugar tea director will only call the parts that are needed. Okay, the milk tea will call all the methods that it's needed. And if you pass to this client, if you pass as an argument the sugar director, then it will go and create a sugar tea. If you pass a milk director, it will go give you a milk tea, right? Yeah. Is it clear?
Yes.
Yes.
So this is how you should go and implement this particular thing, problem, where you will have multiple directors. You can have one implementation of a builder, which prepares all these ingredients for you, right? So these are water, tea bags, sugar, and milk, right? And now you have three directors, three implementations of them. You'll have only one director interface. Don't create three director interfaces, okay? Just one interface and three implementations of the director. The tea with sugar director, tea with this one director, and this one director. And they know which ingredients to use to make the tea. And now in the client, by changing the director, and you have the same builder, but changing the director instances in the client, you can have different teas. Is it clear?
Yes.
Yeah. So you just, if my vending machine, if my manager comes to me and says, you know what, we have a lot of students like, you know, like walking around this tea vending machine, and you know, students, they don't have money, they just want water. Okay, they don't have money to pay for the tea bags. So can you go and make me can you go and write a program that would simply just vent the boiled water? Okay, and he comes and asks me to write a program for this vending machine, which would simply, vent the boiled hot water, nothing else. Okay, can I go and do it without violating OCP, open close principle? Can I do this?
Yes. Just implementing the director and calling only boiling water.
Yes, I'll just implement another director. I'll just create another class, right? And just inside construct method, I'll just say build boil water, right? And then and the client doesn't need to change anything, right? It just need to go and get another director, right? Yeah.
Composition. Yeah.
Yeah. So give the client another director, and it will be able to give you just boiled water, right? So this is I can go and do all these things without making any modifications. Like just adding a new class, it's easy to go and make new changes into my code. Okay, so my vending machine can now add new menu into this this one. So let me switch to my screen. Yeah. Okay. So again, if I want to add, so we got 4 different ingredients here, right? So, and I have 3 different implementations of the director. If I want to create another, this one, then yeah, if I want to create a tea coffee, for example, is it also possible? Like if I want to make a coffee along with the tea, is it also possible? Tell me. Yes, it is possible, because I just need to create another builder, right? Which would, instead of putting tea bags, it will go and put coffee in it, and then give it to another director, because I have both director interface and this guy interface. So I just, again, this could be also possible in my situation. I just need to go and create a different builder, which will, for part A, it will go and give, sorry, for part B, it will go and give me, instead of tea bags, it will go and give me coffee. Okay. Yeah.
Yes.
So yeah, I have 2 builders now. One builder gives me a coffee, tea bags, and part B, coffee builder will give me, okay, coffee instead of tea in that part, right? Right? You agree with me?
Yes.
I don't have to go and change anything in my code. Okay, if I use builder pattern, and it's open for extension, closed for modification. Okay, the third one is an observer pattern, and I'm not going to illustrate code this whole thing. I hope you can do it yourself. Okay, we got the observer pattern. Okay, and the observer pattern is what kind of problem it solves? Observer. What kind of problem it solves? Okay, the observer pattern solves the problem of communicating changes in one object to another object. So assume that observer pattern, first of all, is a behavioral pattern. So it deals with the problems that you may have during the execution time of your program. So in your execution time, you have living objects talking to each other, right? This is how you run the program in an object-oriented world. Right? You have multiple living objects, and now you might have a problem where one object changes its state. Let's say it was busy, now it is free, right? It was busy, now it's free, right? So let's say it's in this particular example, it's indicating the temperature. So the temperature was 20 degrees Celsius. Now it became 22. Okay, so you need to, and other objects should be informed about this change. And this is a very, very useful pattern, because it's commonly used in many applications. It's basically the basis for another pattern that's a high-level pattern, architectural pattern called MVC. Did someone heard about MVC? Does anyone know about MVC? Have you heard about Nvc architecture?
No.
Okay, so Nvc architecture, it's an architectural pattern, and it says model view controller. Again, we will not talk about model view controller. We'll talk about model view controller in some other class called internet programming. But this is an architectural pattern. Okay, again, by the way, the patterns, they can also have multiple levels. We have architectural patterns, which define the architecture of our system. So the layers, okay? So our system is kind of composed of multiple layers, and it decides what sort of layers we should have in our system. Okay, so the architectural patterns, they just group some classes into big like layers, and then say, okay, we need to have a group of models, we need to have a group of views, and we need to have group controllers, and that's the way how they should interact. These are architectural patterns, okay? So we also have design patterns. This is on the middle. And we are talking about design patterns now. Design pattern is just one aspect of your, this is the high level, right? This is the middle level. Design patterns, they apply to one particular problem, okay? That one, but inside your big application, you have one particular problem area and you want to solve this problem area using a pattern. So they give you they tell you how you should be solving this problem, okay? So they give you some hints and clues on solving design problems. And at the lowest level, we call them idioms. And these are mostly language related things. Like if this is not language related. This is not language related. Okay, this is related to, the only restriction that it wants from you is it has to be an object oriented programming language. It doesn't care what object oriented programming language, okay? Like Java, C#, okay, or even Python, okay, or TypeScript, for example. These are object oriented programming languages, and you can go and use all of these patterns for those object-oriented programming languages. Doesn't matter which language you use. Okay, in idioms, you need to know about the language, and there are certain things, okay, preferences that you want to be realized in this language in this way. Okay, and the idioms tell you, okay, in Python, this is the way how you should be realizing things. In Java, this is the way how should be implementing the small code-related things, like it's some syntax sugars, certain things that will make your code readable and understandable and also reusable. Okay, so the idioms are like, these are like the naming variables, for example, or using certain structures over other structures. For example, sometimes you want to use a for loop over while loops, or certain methods, certain libraries for accomplishing these tasks. So again, these are these things. Okay, it come with an experience. Like you're not with working with the Java, and as you go and start programming in Java, you will develop your own library and dictionary of idioms. Okay, so again, why I'm talking about that, by the way, I started with the Nvc architecture. This Nvc architecture is a high-level pattern, and it's based on the observer pattern. Because imagine that you have, let's say, an object. It could be student, or it could be temperature, whatever. This object is living object. This is the student, and then the student has, let's say, the name, and he has the grade, right? So now this is the object. It contains all the data. But now you have, let's say, GUI. It could be a web GUI or desktop GUI, doesn't matter. And it's a GUI. Okay, and then you have a panel called student info inside this GUI, right? And this panel contains some text boxes. Let's say the name and the grade. Okay, so this text box shows the student's grade, right? So if the grade of the student changes here, does this guy need to know about this? This text box is another object, right? It's just a separate object. Its job is to display you a text box in a graphical way. It's just different object. It's an object too. This is an object too. These are two objects living inside our application. But if this value of this object changes, should I tell this object about that or not?
Yes.
Yes, right? So this guy needs to be notified about any change that happens inside this object. So if I have this problem, then I need the solution to make it work. How can I make it work? So in order to make it work, I need to use the observer pattern. So observer pattern has two participants, okay, big participants, the subject or observable, subject. Sometimes people say observable. And it has observer. It's observing, okay? That's why it's called observer, as the name of the that. So this guy observes this guy, and if some change, if this guy watches this guy, and if anything happens here, it should be able to detect this change, right? So how can we implement that? Can we implement that? Yeah, I talked about that in the lecture, but let me go and visually explain you this thing, and you can go and implement it yourself. Okay. So what do we want to do here? Okay, first of all, let me explain you the task. What do we want to do here? So we have a weather station, and this weather station, I already gave you the implementation, like partial implementation of the weather station. It uses the timer and the timer task. So let's say every 5 seconds. So I left some code where you have to write your own code, right? So every 5 seconds, it goes and updates the temperature, the humidity, and the pressure. This is just a weather station. Let's assume that it's taking these values from some remote server, or maybe it's just getting it from sensors. Okay, this program maybe could be running inside some weather station, real weather station, where it goes and pulls all the records. Also all the data from the temperature and humidity, and basically keeps and updates all that stuff. Okay. Now what I want is I can have multiple displays attached to this. Okay, weather station. One display should display things in Fahrenheit. The other one should display it in Celsius. So I need to have at least 2 devices which display the things in 2 different ways. Right. So they need to print out as this weather station changes. They need to print out 2 messages at least. They need to be informed about this, and these are devices. So now, okay, I want to solve this problem using the observer pattern. So let me go and create. Let me go and create the whiteboard so I can explain, at least graphically, and you can implement it yourself. So in an observer pattern, again, we can do everything in terms of abstractions as well. So I can go and let me just draw the squares. So I have okay, so yeah. Or I can go and create this interface. Let's deal with interfaces. Let's deal with yeah. So in this case, this is the okay, cool. So now I need to have a subject. Right? And inside the subject, so this is an interface. Let me go and make it as an interface, right? Because I want it to be, or abstract class. You can call it as an abstract class, right? Yeah, let's make it an abstract class, because certain methods are they repeat. I don't need. Because certain methods, I don't need to re-implement them all over and over again. It's just an abstract class, right? Okay, so, but in Java nowadays, you can even implement methods like default methods, okay? So it's the new feature of the Java. It wasn't there at the beginning, but now we have interfaces which can implement certain methods as default methods. Previously, we used abstract classes for that purpose, okay? Good, so we got an abstract subject, okay? So this abstract subject has what? What's the name of this?
Observer.
Exactly. So this is also an interface. It can be an interface, by the way, because there's nothing that we could re-implement. So this aggregates, not composes, aggregates 0 to many observers, okay? 0 to many observers. And we have some array which contains that here. So, right? So this is the observers lists, and now we have like 3 methods here. So, okay, we can call it attach, and it takes an observer, and detach. Okay. Another observer, and notify. Okay. So these methods, okay, I don't need to go and explain you all of these methods. I think it's self-explanatory, but okay, notify is basically for observer O from all observers that you have. Take O from all observers, right? And then you say, by the way, your observer has a method called update. And it takes subject. Or yeah, you can. So again, it depends on the context. Okay, this update could be just it can take some argument, but it may not take some argument. Okay, because if you say take some argument, then you're making your observer dependent on this subject. But okay, let's go and say subject anyway. Okay. Okay, good. So it's a subject. So now what do we do here is we say update and then we say this. Okay? You got it? So now we can go and implement the extend the subject, and we can call it the concrete subject, which has some bunch of other properties. Let's say, I don't know. The property is I don't know. Let's say the temperature, right? And inside the temperature, okay, if you have a private temperature value, so then you have a value called temp setter, right? Setter, and let's say it takes integer. So what you normally do here is you say this temp is equal to value, and then you say this notify all. After changing the state, you always call this notify all method, okay? So because set is going to change the internal state of your subject, as soon as you go, because you have a setter, right? After changing this something, you're going to say this notify all, right? This is something that you should be doing for every property that you have for the derived class or for the subclass of subject. You got it? Is it clear? Hello?
Yes.
Yeah. So now you have concrete observer, right? So we can call it observer 1, observer 2, right? And they have, let's say, they go and let's say they display the temperature. For example, this observer is some sort of is a text box, and text box is a value property, right? So this could be some text box. This could be some weather station. So okay, and so it has to implement update method, right? So what does it do to implement the update method? What does it do? So it takes, remember, it takes the subject as the input. What does it do? Hello? It says this value is equal to subject
Temp.
get temp, right?
Mhm.
Right? Where it can access this temp parameter, right? Yeah?
Yes.
You got it?
Mhm.
And this guy may have something else. Maybe it may have some other method. Let's say, I don't know, caption. Something like that. Again, you don't know what is this observer. It's all you know is that it has to go and implement the update method, right? Yeah. Okay. So now you can go and implement update method. It takes this one, and you can update the caption, for example, if you get the subject. Okay. Let's say this text box is. Let's go and say this is just a value again. This is another text box. This text box is a temperature text box, and we might have a text box for humidity. Right? Right? You agree with me? And here it goes, and when you say update, it goes, and instead of saying get temp, it goes and says get humidity, and updates the value, right? For humidity, right?
Yes.
You agree with me? So it goes and
Mhm.
updates itself. This guy gets updates itself. Every time you go and make change using setter, right? Setter, you're calling notify all. So all of the observers are notified, okay, about the change, and they go and update their internal states based on the change that happened here, right? So if you in the client part, what you're going to do inside the client, what client will, how client would use it, it will go and create an instance of a subject. It will go and create instance of observers, right? You have instances of observers, you have instance of a subject. You attach these observers into the subject and then keep changing the subject, right? Every time someone goes and changes something inside subject, these guys will be automatically notified about it, right? You agree with me?
Yes.
Okay. So you got the idea, right? How are you going to implement it? So this is the observer pattern, okay? You create subject, you create observers, you attach observers to the subject, and then your subject is free to, okay, to travel the code. And you can go and change your subject as you wish. As long as you go and change the subject, all the changes that happen inside the subject will be automatically pushed to your observers. You don't care about observers. Observers are then automatically updating their states too. So you are working with the subject. Your code is working with the subject. Okay, is it clear? You don't have to go, let's say your client doesn't have to go and update all the observers over and over and over and over again. You can just create one subject, register the observers to this subject, and deal with the subject everywhere else. You got the idea? So it makes your code easier, right? You got the point. Is it clear?
Mm-hmm. Well, Professor, for example, if we create the subject of humidity, we have to extend it from abstract subject and then
No. This is not subject of humidity. This subject is called weather station, and it may contain humidity as well.
Another humidity. Mm-hmm.
The weather station contains humidity, right? It's not like subject is not just one variable. It can contain a bunch of other variables. This subject is some object which has an internal state, which internal state is just basically some properties, right? And these properties tend to change during the execution time, right? Your problem is you want other objects to know about these changes happening inside this object, right? This is the problem. And solving this problem is implementing the observer pattern. So you need to have a list of observers. You should be able to register the observer, detach the observer, and notify all the observers. And inside every setter that you have to call, after setting the value, you have to call notify all inside every setter. Okay? Got the point?
Yes.
And if you do this, and you go and implement observer for this one, and you decide what you want to do with this change. Okay, for example, this observer, if it's a text box and this text box is showing a temperature, right? Then you care about the temperature, so you go and get the temperature and then update the value here. This text box is a humidity text. I mean, this text box is showing in your application the humidity, so you care about humidity, so you're going to say get humidity. And you update your humidity. So now, okay, this is happening here, but the weather station, which is modifying all that stuff, it doesn't care about how processing the data. Again, its job is just to update the temperature and humidity, and it doesn't care about what's happening here and here. It shouldn't know anything about what's happening here. These observers can attach, they can come and go during the execution of your program. And it should not affect the subject. Subject is something it can change on its own. Observers can come and go, right? You can go and they can register themselves and then watch the subject. And once they don't need to watch the subject, they can unregister themselves as well. You got the point?
Yes.
So that's the main idea behind observer pattern. I hope you can go and do this task yourself. I don't need to go and show you the code. Okay, so this is basically that task. I already gave you the code for running the weather station. So perhaps you don't know how to run the timer and timer task because we haven't covered the multi-threading. So it's kind of related to a little bit multi-threading. So that's why I gave you the code. You just need to go and fill the parts that are not written, like this part and this part, and you just need to go and create some two observers. This code doesn't contain observer, so you have to create it yourself and then write all the things here. So once you start this weather station test file, it should run every 5 seconds and then update the temperature. So this update parameters can update the temperature, humidity, pressure, and as it goes and updates things, all the observers that are attached to it, they should update their state as well. So you just need to print out perhaps every time something changes in the subject, the device 1 has to print out, let's say, the temperature in the Fahrenheit, device 2 has to print out the temperature in Celsius. Got it? Yeah?
Yes.
Is it clear? Good. So so I think this is the one. So the last one is the factory method. And I think this explains, this particular pattern explains the idea of dependency inversion in its all glory, okay? Because this is the place where everything changes, okay? So what is a factory method? Factory method, first of all, before we go and understand the factory method, we have to understand the problem of having a code something similar to this. So we have a code like pizza store. And this pizza store has a method called create pizza, and takes 2 arguments, and it returns pizza. And we got a bunch of objects that are kind of some objects that implement the pizza, okay? Different types of pizza, different flavors of pizza. Okay, so you look into this code and tell me what is wrong with this code. Does it violate any of the solid principles? Hello? Does this code violate any of the solid principles? Okay. Okay. Check the dependency inversion principle, right? What does it tell you? Dependency inversion principle, what does it tell you? It tells you that everything has to depend on abstractions, right? Right? There shouldn't be a concrete class which depends on other concrete class, right? Right?
Yes, yes.
So we have a concrete class called dependent pizza store, and okay, and it depends on what?
On pizza. Pizza
On
class.
no, okay, this is okay, this is fine, this could be an abstraction, no problem. I'm more worried about this thing. What is this? It is a concrete class. This class depends on this class. This class depends on this class, right? This pizza could be an interface or something, right? There's nothing that suggests that this pizza is, in fact, a concrete class. We don't know, but here we 100% know that this is a concrete class, right?
Yes, yes.
So we look into this, like our pizza store is dependent on so many concrete classes. And this is against the rules. This is against the dependency inversion principle. And we should solve this kind of problem. We don't want our pizza store to be dependent on concrete classes. So how can we go and solve the problem? So let me go and create a new package, call it pizza store. So inside a pizza store, what I'll do is I'll go and create public static start. It's going to test my pizza store app. Okay, good. So now I would like to show you how this method works. So let me go and so now now I have this pizza store, which is kind of going to create me and it has a lot of dependencies, right? We saw that. So what we want is we want to loosen up these dependencies. So how should we loosen it up? So it has this create pizza method. Let me call it create pizza. And it returns another an abstraction called pizza. Okay, so pizza has prepare method. Pizza has bake method and cut and box, something like that. These are just the methods of the pizza. And it is okay, it could be an interface, right? No problem. Or it could be an abstract class. Let me make it an abstract class because there are some repeating parts. So it's an abstraction anyway, right? It's an abstract class. Now I have, okay, different types of pizza. I have NY, New York style, okay? Cheese pizza. And NY, let's say veggie pizza. And I can have Chicago cheese. And I have Chicago veggie. Yeah, so veggie, let's say. Okay, these are all concrete classes. Okay, now in my current implementation, my pizza store is dependent on all of these classes because it's directly instantiating all of those things, right? Yeah, do you agree with me?
Yes.
So see how it's dependent. So I don't want these dependencies. So how can I eliminate these dependencies? Okay. So what should I do?
Using their abstract class.
So now I can go and create. a special class. See, instantiation is so crucial, okay? Creating new objects in my code is so crucial because, I mean, without it, you cannot run a program. You have to create objects because objects are the living things in your program. Without objects, you cannot run anything in your program. You need objects, right? But you don't want to create objects everywhere, okay? Because if you go and create objects uncontrollably everywhere in your code, then it means that you're creating dependencies. Every time your classes are getting tightly coupled. You don't want this thing. You don't want two classes to depend on on concrete classes because you would later on you want to change this implementation of this class to something else. So that's the reason you don't want your instantiations scattered all around your code. You want to delegate this thing to a special class called factory method. Or sometimes there is a generalized version of it called abstract factory, which deals with family of objects. But in this case, I'm just showing you factory method. Okay. Good. I'd rather say it's because we got to deal with the family of objects. Okay, so I'd rather even call it as a. Okay, yeah, it's not a factory method in this case. What is in my mind is abstract. Factory method only deals with one single object. Abstract factory deals with the family of objects. So we have family of objects here. So I'll call it abstract method. Abstract factory. Let me call it simply pizza factory. And it could be interface. It is an interface. Okay. Okay, so now it has it has two methods, let's say, create cheese pizza, and it's associated with, it returns a pizza, just a pizza, right? And it has another method called create, what is that, veggie pizza. And it also returns, it returns pizza. So it's associated, interface is associated with pizza. Now I can have multiple implementations of this pizza factory, right? So now I got NY, New York Pizza Factory. And I have Chicago Pizza Factory. And they actually implement create cheese and create veggie. Okay, but this time, this create cheese will return this guy will return this one. So it is associated with this guy, with the concrete class. This concrete class is associated with this concrete class. This is associated with this concrete class, and so forth. Yes, we are violating dependency inversion principle here. We are violating it. We have to violate it because otherwise we cannot create objects, right? So, but the good thing about this is that we are doing it in one place. Okay, we're doing it in one place. So this guy is associated with these subclasses. You got it?
Yes.
Now this pizza factory represents one family of objects. This pizza factory represents one family of objects, right? So this family of objects, it's just a bag of objects, right? This guy is a bag of objects, some different set of objects. This is a different bag of objects, right? Right?
Yes.
Now my pizza store can take a pizza factory as an argument, can compose, sorry, not associated, but aggregate, compose, can be composed of a pizza factory, right? Yeah? You got the point. Now, depending on what sort of pizza factory I give to the pizza store, it will deal with this, only with this family of objects. If I pass this guy to my pizza store, it will be dealing with this set of objects, right? Yeah?
Yes.
If I pass this guy, it will be dealing with this set of objects, right? So imagine a different example. Let's say this is not a pizza store. This is a word application. You wrote a word processor, and this pizza is not pizza. It's just a control, Gui Controls, and this is a text box. This is a button, and this is the list, and all the Gui controls that you have. And this is just the generalization of a control, which is just idea of a control, right? It's an abstract control. And these are real controls that you can see on your screen. This is your word processing application, right? Now you can have a Windows controls factory and Mac controls factory here, right? And you have different methods for creating buttons and creating lists and all that stuff, right? Yeah. Yeah, agree?
Yes, yes.
Now, if you want your program, your word processor to work with Windows machines, what you should do? What you should do? You should just need to create this Windows controls factory, which goes and creates all these buttons and everything for you, right? Right? And pass it to your word processor. You pass this pizza factory to your word processor. Now your word processor works on Windows, right? It can draw all the windows and buttons and everything because it has the Windows control factory, which knows how to create all these controls for this guy, right? Yeah.
Yes.
But if you want your word processor to work on Mac, not on Windows, then what you need to do? You need to pass this guy, this is a Mac controls factory, right? To this guy, to the word processor, right? Now your word processor is drawing different buttons. It's drawing Mac buttons and it's running on a Mac. The logic of your word processor is exactly the same. It doesn't change from Windows to Mac OS. The controls may change, the GUI controls may change because the GUI controls are managed by the operating system, right? So they may change. It's okay. It's okay. You just give a different factory to this. And it will be dealing with different objects, different set of objects inside the prog, inside this application. It is just one example. In this case, your entire application, everyone who is living in this application, this population of objects, okay, living inside this application now can be controlled by one single class, right? So if you're testing something, right? So if you're testing, you want to test one particular class, but you don't want to test any other classes. You can go and create a different factory where there's only one class that you want to check. Every class is a mock class, doesn't do anything meaningful, just returns a fixed thing. You can create this family, this factory, which gives you this mock objects everywhere, but one object is something that you want to test. And then you pass this factory to this application. Now, application will use this factory and get all necessary objects from this factory, right? Yeah, and it will go and test, and it goes and runs your application, but with different set of objects, different implementation. You got the point?
Yes.
You can change the entire implementation, the entire implementation of your application by just replacing the factories, the instances of factories that are passed into this, okay, into this pizza store. You got the power of this whole abstract factory method. It can change the entire implementation of your application, pizza application, concrete implementation of your pizza application by just simply replacing the factory that it uses. Okay? You got the point?
Yes.
So this is yes.
For what reason do we have, for example, between pizza store and abstract pizza, we have a connection? For what reason?
Where? This here?
Yeah, here, yes. This one.
Yeah, because this create returns a pizza, abstract pizza. It's dependent on this interface. This create method returns a pizza, right? Yeah. That's why this pizza store is dependent on this abstraction. Okay, it can also depend on it also depends on this pizza factory interface, because it either aggregates it, it's composed of it, or it can take it as an interface and so forth. As an argument into its constructor, something like that. So this means that okay, if it's a composition, then it means that this guy, it has to be passed into the pizza store to create a pizza store, right? Yeah. I mean, again, there is no clear-cut definition. Okay, to be honest, there is no clear-cut definition of composition and aggregation. Okay, Like many literature uses a different purpose. But for me, it's very clear. Like me, for my own kind of idea, the composition is this object can own this thing, okay, and it cannot be owned by someone else. Oh, you know what? I think it's an aggregation. Yeah, it's an aggregation. Why? Because this pizza factory can be owned by someone else as well, right? That's something. If it's a composition, then this guy cannot be owned by some other object. Okay. Pizza store pizza store composed of pizza factory means that there is this pizza factory is the part of pizza store. It cannot be part of someone else, right? So for example, car has an engine. So car is composed of engine. So it means this engine belongs only to this car. It doesn't belong to someone else. That is the meaning of composition. Aggregation doesn't have this meaning. Aggregation just is just a one-way dependency. So for example, pizza store can aggregate pizza, but this means that, okay, pizza cannot aggregate pizza store. Okay, you got the point. Aggregation is a more loose definition. So it means pizza store can aggregate a pizza, but pizza cannot aggregate pizza store. And by transitivity, you mean that, like, if you have a third class, if pizza store aggregates pizza, pizza aggregates some other class, then this class should not aggregate this class. There shouldn't be any cycle, okay? That is the kind of the official definition of aggregation and composition. But when I say composition, I usually mean something that get passed into the argument while initializing this object, because it's just a part of it, right? But in this case, pizza factory can be passed to someone else as well as an argument. So I just leave this as an aggregation, okay? This pizza factory can be used by someone else, not necessarily this particular app. Okay, so this is just my point, right? So you're passing this guy is dependent on pizza and this guy is dependent on pizza factory. Note that this guy and this guy are all abstractions. So this concrete class is dependent only on abstractions, right? This is a subclass is depending on abstraction. This is depending on abstraction. The only place we are violating this dependency inversion is this class, where concrete class is dependent on another concrete class. But okay, it's fine, because this is just one place it's happening. And it's just encapsulating all these dependencies in one place. And it's kind of describing the family of objects, right? This is a family of objects. I need family of objects to be passed into this store to make sure that this pizza store works. I can change this family to a different family, depending on the context, depending on if I want a different implementation, okay? So by just creating different pizza factories, I can change the entire implementation of my application. You got the point?
Yes.
So this is extremely powerful design pattern. And because it's so important and so powerful, there are frameworks based on are built on top of it. Okay, so you don't have to implement all this like methods and everything. Okay, you can use something called the dependency injection frameworks. Dependency injection. Dependency injection framework. And in Java, it is in Spring, I guess. If we will have time by the end of the semester, perhaps we're going to talk about this framework. But the Spring framework contains this dependency injection feature. So what does dependency injection do? It provides you some class called service container, where you can register different instances that you would like to use inside this application. It's kind of a registry, right? You say, if someone wants if someone wants if someone wants a cheese pizza, so you have a cheese pizza, right? Then give him the New York cheese pizza. If someone wants a veggie pizza, give him a New York veggie pizza. So you're going to make these kind of mappings, right, everywhere, right? And then you can go and create objects with constructors. And inside the constructor, you can ask for objects that that you would like to have, or you can ask directly from the this special class called the service container to resolve you a particular interface. So for example, you need a pizza. In this case, you just say, give me a cheese pizza, I cheese pizza, and it's going to give you a New York cheese pizza. Because you registered for I cheese pizza, you registered New York cheese pizza, okay? So you resolve an interface to an object, and this container is, sometimes it's in some configuration file, sometimes it's just something as well, it's also a compiled file, but the point here is, it's just one file. And in this file, you can change and replace the mappings of interfaces to real objects. And by just changing the mapping, you can change the entire implementation, okay? You got the point. That's the role of a dependency injection framework. And it provides you an entire library of doing this thing, okay? So you don't have to implement your own dependency injection framework or your own abstract factory in order to do this. You can simply use, if you want to implement abstract factory, you can simply use a tool called dependency injection. Inside Java, it's a Spring. Inside .NET, I'm a .NET developer. There are a lot of them. Autofag is the one people commonly use. Okay, there is also Castle Windsor project, and so forth. Or Microsoft's Unity. It's not Unity 3D, it's a Unity, and it provides you dependency injection. So for C#, because I'm a C# developer, kind of, right? I know many libraries that help you to do the dependency injection. I'm kind of not from Java world, to be honest. And that's why I just know that the Spring is the one which gives you this thing. But if you can go and explore Java world, perhaps you're going to find some more libraries for dependency injection, okay? Is it clear?
Yes.
Cool. So I think we don't have time to implement this whole thing, but the good thing is I already uploaded the RIS video, and in the RIS video you can see the actual implementation of this structure. So I don't want to spend your time right now, but the implementation is given in this yesterday's recording. Okay. I'll also upload, I think, this video as well. Because we covered Builder and Observer in this particular RIS. So I think others can also watch that and then understand how to solve the problem. This particular thing is already implemented in the previous, in yesterday's recording. So go and watch that and you're going to see how it needs to be implemented. But I think you already understood how it should be done, right? Yeah?
Yeah. Yes.
Okay. So any questions so far? Okay, someone wants to ask a question about midterm. Okay, can you go and ask your midterm question? No problem. So I think it's Muhammad Amin wants to ask. Muhammad Amin. Hello, Muhammad Amin. I think he's out. Okay, so any questions so far? Okay, I recommend you to, yeah, someone wants to ask a question. I recommend you to, let me clear my screen. Is it okay? I can clear my screen. So I recommend you to go and read these books. And these are not just the books that you will have to read for this particular semester to get a good grade, but these books should be like your desktop books, your reference books. You always need to keep these books with you if you want to work as a professional software developer. No matter which language you use, no matter which technology you use, as long as you're in the object-oriented world, okay? If you're in this world, then you should keep these books with you all the time, okay? So these books tell you, there are many other books as well. I would recommend you to read the Clean Code book as well. It tells you about more about not patterns, but idioms. So I remember I said about idioms, right? Low-level things that you need to be doing while coding. So if you want to learn more about idioms, then I recommend you to go and read Uncle Bob's Clean Code book, and you can find it over internet if you want. It's a clean code. It's the book name is called Clean Code. Let me show you the Clean Code. So this is the book. Yeah, it's a bit old book, but I think it's still valid, and it gives you good understanding. And another good book that I would recommend you to keep with you is the Pragmatic Programmer book. I don't know if you heard about this book. There is the new version of this book, so I recommend you to find this book and read it as well. This is mostly about how you guys need to collaborate with each other. More about how programmers work together as a tribe, right? So like it's kind of about team building, and certain values that you should adhere yourself if you want to be a good programmer. Okay, and if you want to develop a grandeur and masterpiece projects, a really good projects, great projects that continue living even like in 10, 15 years. They don't rot and they don't deteriorate, they don't go away. They continue developing and thriving. If you want to build such projects, then I recommend you to go and read this book as well. These are like key books, like every software developer should read in their lifetime. I'm not asking you to read all of these things within this semester, but you can keep these books with you as a reference book, and if you keep reading it from time to time, you'll learn a lot of interesting things, and then kind of profess in the area of programming, at least. So this is just my advice to you guys. And this lecture, as I said, is one of the key lectures of this semester. So I want you to read everything and learn that. Anything else, guys?
No, thank you.
Cool. Yes.
Can you give some information about midterms?
Yeah, information about midterm. I think I already posted in Telegram. Did you see my Telegram message about midterm?
Yes.
Zalola, did you see the message in Telegram?
No.
Yeah, please check your Telegram channel. Okay, I already posted information about the about the midterm. Please go and check that. I think you have all the information that you need at this moment about the midterm. If you still have questions, then you can write an email to me, and I can also answer all these questions. Okay. But first, please go and check the Telegram post that I made related to the exam.
Professor?
Okay. Yes.
And how many practical questions we will have in the midterm exam?
Right now, I cannot tell you. Okay, 3 or 4, maybe 3. Okay, it depends on the complexity of the questions. Okay. I cannot tell you exactly right now, but you'll have, like, if you have easy questions, you might have 4. If you have difficult questions, you might even have 2. Okay. Is it clear? Is it clear?
Okay, thanks.
Okay, good. Anything else? No more questions? Okay, then I recommend you to guys go through your quizzes, go through your lab exercises one more time, because I already mentioned you might have some questions from quizzes and your labs in this exam. So if you go and repeat all those things, it will be easy for you to answer the questions, okay? So go and check all the quiz questions and practice lab questions one more time. Just go through them and make sure that you know the answer for all of these questions. So this way you can nail the exam. Okay. Is it clear?
Yes.
Good, good. So, so then, if you're okay with that, then I wish you great success to your exams, and make sure that you excel at it. And then we're gonna meet maybe after the exams, right? We're gonna meet after the exams. We are not going to have, obviously, we don't going to have RIS during the exam week. Okay. So thank you for joining this RIS and being here all over, I don't know, for 2.5 hours. I know it's very painful, but anyway, thank you very much for being here.
Thank you too, Professor.
Yeah. Okay. See you. Bye.
Cool.
Goodbye.
Goodbye.
Goodbye.